In this video, we'll introduce you to the idea of partitioning. So first things first, what does it mean to partition something? Well, the definition is right there at the very beginning. Partitioning something means to break it up or divide it up into a certain number of pieces, usually according to a ratio that's given to you. Now, midpoint is a way of partitioning a segment. Midpoint will partition a segment into two equal pieces, but now we're going to look a little beyond that and become a little more sophisticated with our dividing up. In this first example, it says we're given line segment AF that has been divided into 5 equal parts using points B, C, D, and E. And in part A, they want us to find point P such that the ratio between AP and PF is 1 to 4. So in other words, I want the distance from A to P to make up one of those 5 pieces, and the distance from P to F to consist of 4 of those 5 pieces. So if that's the case, if A is one endpoint and F is the other endpoint, the point that I'm looking for to divide that into a ratio of 1 to 4 would be point B. So point P is going to go right here, such that A to P consists of one of the 5 units, and P to F now is made up of 4 of the units. So in this first example, the location of point B would be placed at B. All right, I'm going to erase so that I can kind of start from scratch for the next one. It says in the next one, find point Q such that the ratio between AQ and QF is 3 to 2. So A is one of my endpoints, F is the other of my endpoints, and I want A to Q to be 3 of those pieces, and Q to F to be made up of 2 of those pieces. So it looks like point Q must be located at point D. And then lastly, find point R such that BR to RE is 1 to 2. So this time my 2 endpoints are at B and at E. So I'm not even going to look at the piece of the graph that lies to the left of point B or to the right of point E. And I want B to R to consist of one of those 3 pieces, and R to E to consist of 2 of those 3 pieces. So it looks like, again, R must be located at point C. So notice that for each of these questions, when the ratio was 1 to 4, we had 5 pieces total. When the ratio was 3 to 2, we had 5 pieces total. When the ratio was 1 to 2, we had 3 pieces total. So the total number of pieces can be found using that ratio. That's important to know. Okay, a directed line segment is a line segment that starts in one place and ends in another. So directed line segment AB would start at point A and ends at point B. That's important to know. We have a direction. We have a starting point and we have an ending point. So again, that's the big key idea with directed line segment, a starting point and an ending point. All right, so let's go partition some segments. In example 1, it says we have this line segment AB with endpoints A at coordinates 3, 4. And I'm going to immediately jump into this and start graphing. So there's A. And B has coordinates 6, 10. And on my page it says find the coordinates of point P along that directed line segment such that the ratio between AP and PB is 3 to 2. This should be 1 to 2. So if yours is like mine and says 3 to 2, you can go ahead and change that right now and make it 1 to 2. And if we wanted to, we could do some fancy counting on the graph, but there's actually a very easy, simple algebraic way to do this. The directed line segment AB starts at point A, so I'm going to start with point A, who has coordinates 3, 4, and ends at point B, with coordinates 6 to 10. And I know, due to the ratio, that I'm going to need to break this line segment into 3 equal parts. So I'm going to do one point that'll break up the first part, a second mystery point breaking that line segment into the second of those 3 parts, and then lastly, I want my line segment to end at point B with coordinates 6, 10. And what I'm going to do is I'm going to take a look at the change in the x values first. So in moving from 3 to 6, for the x values, that was a net gain of 3. Then I'm going to need to divide into 3 equal parts. So 3 divided by 3 tells me that change for each one of those x's over each part is going to have to be a plus 1. So if I'm starting with an x value of 3 and I'm increasing it by 1, that becomes a 4, increase by 1 more becomes a 5, and increase by 1 more brings me to 6. That's a check to know that I did those increases correctly. If I apply the same exact idea to the y values, this time in moving from 4 to 10, it's a total increase of 6 that I want to break into or divide into 3 equal parts, making the change over each part a plus 2. So again, starting at 4, I want to increase each time by 2. So 6 increased by 2 more brings me to 8. Increase by 2 more brings me to 10. So there's a nice little check telling me that I indeed did this correctly. If I'm a very visual person and I want to take a look and see what this might look like on a graph, there's 4, 6, there's 5, 8. And I want to break this into a ratio 1 to 2. So my point P is going to have to go here, such that from A to P is making up one of those pieces, and P to B is making up the other two. Therefore, the coordinates of my point P are 4, 6. So there's a nifty little algebraic way of solution. At this point, if you need to, I'd go back and rewatch part of the video, or if you have questions, jot them down in the margins so that if I don't answer them in the rest of the video, you can remember to ask the next time that you come back to class. In the meantime, I'm going to go ahead and scroll down and we'll take a look at that second and last example. In my problem, I have a couple typos that I'm going to need to fix. It should say line segment AB has endpoint A with coordinates 6, 10, and it should say B with coordinates 5, 4. Find the coordinates of point P along that directed line segment such that the ratio between AP and PB is 2 to 3. I'm going to use the same exact strategy that I used in the first example. And again, if you're a very visual person, you might find it really helpful to go ahead and graph these points. So there's AB, there's directed line segment AB. Remember that directed line segment AB starts at A and ends at B. So again, if I lay this out like I did with the first one, point A with coordinates 6, 10 is my starting place. That ratio of 2 to 3 tells me that I'm going to need to divide this line segment into 5 equal parts. So there's one of those parts, 2 of those parts, 3 of those parts, 4 of those parts, and lastly, point B, the 5th of those parts, is going to net me or get me to the point whose coordinates are 5, 4. And again, what I'm going to do is I'm going to employ the exact same strategy. I'm going to start at A and end at B, and I'm going to look at the net difference or the net change in the x values. I'm moving from 6 to 5, which is a change of -1 that I want to divide up evenly amongst 5 equal parts. And this is where my calculator is going to be very useful and very helpful. So I'm going to go ahead and flip over to my calculator. You should get your calculator out as well. So if I want to go ahead and calculate I'm going to type in that fraction, 1 over 5. And just a reminder that unless you either hit Control and then Enter, or hit the decimal point and then Enter, your answer will always be given as a fraction. So I'm going to put the decimal point in there. I guess I'm not going to put the decimal point in there. I'm instead going to hit Control Enter, and it tells me that each of these changes is going to increase by zero point 0.2. Sorry, decrease, because I'm going in a negative direction. So 6 minus zero point 0.2 is 5.8, 5.6, 5.4, 5.2, and a check, I end at 5. And now using the same strategy, moving from 10 down to 4 is going to be a decrease, or a minus 6, that I'm dividing into 5 equal parts. And again, I'm going to use my calculator to go ahead and do this. So 6 over 5, and I want to do a Control Enter. Let me go back and try that again. Control Enter. There we go. So this time I'm going to decrease each time by 1.2. So when I subtract 1.2 from the 10, I end up at 8.8. Subtract another 1.2, and I end up at 7.6, so on and so forth. And again, when I subtract the last 1.2, it does bring me to 4, so there's a nice little check that I've done this correctly. Notice that this would be much more difficult to do on the graph due to the fact that all of these points in between A and B are fractional points, or decimal points. I want the point that breaks this into the ratio of 2 to 3. So I want my distance from A to P to make up 2 of those 5 points, and from P to B to make up 3 of those 5 points. So my point P now is the point with coordinates 5.6, 7.6. So this really isn't anything more sophisticated than some division and then some addition and subtraction to move throughout the segment from one endpoint to the other. As always, I'm going to have you summarize in your own words the key ideas and important takeaways from this video, and then see if you can use your newfound knowledge to go ahead and do those questions on the next page. As always, I want to thank you for the gift of your time in watching the video.